So students, we have seen that gravity and how gravitational force differ with each other and how the earth is pulling every object on this planet towards itself. So now we are taking the new topic, that is the beyond the earth, that is universal law of gravitation. Yes students, so I have told you that the gravitational force is any two bodies attracting towards each other, or we can say any two bodies are applying gravitational force on each other. Okay, so here is the universal law of gravitation, that because we know here are lots of celestial objects and that lots of celestial objects are actually applying the gravitational force on each other. Now what certain rules and regulation we can make that, so that we are having a certain formula. अब हमें एक formula चाहिए. So that formula would be help us to define that how much gravitational force is applicable between these two objects. Let's suppose मैं आपको कोई भी example दे दूँ. We are having a Uranus and a Neptune. So ये दोनों बिल्कुल पास में planets हैं. Now are they not attracting each other? Yes, they are attracting. अब वो कितना gravitational force होगा वो हमें define करना है. So for that we should have any particular formula for that. So here we are learning, we are having the universal law of gravitation. What is this? That every body on earth attracts each other or every other body. That is, we can say that force is exerted by all the bodies. Like earth is pulling, but the other objects are also pulling or applying gravitational force on the earth. So we can say that this indicates that the force is exerted by all bodies. Yes, this is true. Now with the force, that is the gravitational force. Okay, so every body on the earth attracts every other body with the force. Okay, now that is the gravitational force, which is directly proportional to the product of their masses, and it is inversely proportional to the square distance between them. So here is the rule. Yes students, that let's suppose we are having two objects, two celestial objects you can take, or any two objects in this solar system. Any example. Okay, let's suppose we can say that this is a planet 1 and this is a planet 2. These are the random planets. So this planet is having a mass. This is a little planet. Okay, so it is having a mass m and it is having mass capital M. We are supposing that. Okay, and the distance between these two mass, and mark my word dear students, here the distance should be taken from the center point of the planets. ऐसा नहीं लेना है आपने distance that you can take a distance from here or here कि इनकी surface से हमने distance को measure किया है. No, we have to take the distance from the center point. Okay, always. And that can be denoted by r. Okay, in question and answers part you will get the distance. Okay, you are not telling कि हम नहीं बोलेंगे आपको कि आपको जाकर के distance measure करना है. Fine, so you will be given the distance between any two things or any objects, and the mass would also be given. You just need to take the formula in your mind and put all the values inside that and then solve the question. But what is that formula? This is very important because we are talking about the universal law of gravitation, not even this. Like if you want to become a scientist, that would be very helpful for you in future. Okay, so this force, the force that has been applied by this and the force that has been applied by this, you have read that the third law of motion, that every action has equal and opposite reaction. So the force that has been applied by this and the force that has been applied would be equivalent to this, to the system. Okay, ऐसा नहीं होगा ये कम ज्यादा. हाँ, ये तो होगा कि ये इसको अट्रैक्ट कर रहा है, ये इसको अट्रैक्ट कर रहा है, बट इस पूरे सिस्टम का ग्रेविटेशनल फोर्स तो एक ही होगा ना. लाइक अगर हम अर्थ एंड स्टोन की बात करते हैं, देन दैट द अर्थ इज पुलिंग द स्टोन. So we are talking about this whole system, that the earth and the stone is here in the system. So the gravitational force, whatever is the result is coming in this case, we can say that the force of attraction between the stone and the earth would be this. Okay, we are not judging that the force is only applied by this earth planet. In this case also, we are not judging that any one out of these two planets are applying a force. We only say that the force of attraction applied by these two planets would be this. Okay, so you got this thing, that the gravitational force we are talking here is about the system, not about the particular planet. Now, what would be the formula? As you have seen here, the third point, that the force of attraction is directly proportional to the product of the masses. So here we are having M and M, capital M, as the masses of these two planets. And the force of attraction is inversely proportional to the distance between them, to the square of the distance between them. Okay, so जितना भी distance होगा उसका square करके आपको उसका inverse करना है. That means अगर distance greater हो गया है तो force of attraction कम हो जाएगा, अगर distance कम हो जाएगा तो force of attraction increase हो जाएगा. ये ऐसे ही है, like a magnet also you have seen that if you are taking a magnet here and iron rod here, so if these are two placed here at this distance, so the force of attraction between these two would be less. But when we bring them like close, now the distance is getting less, but the force of attraction is extended. Now if we like lose it, अगर हमने इसको जैसे ही छोड़ा, then it will suddenly fall on it and get attract towards it. Okay, so that is why we can say that distance plays a very important role here. Okay, so now combining these two terms, now we will get the term like that force is directly proportional to M and M here and R square. Okay, and again the proportionality sign can be removed, and here we will place the constant K, and that constant by the value here will give you certain thing, and that you are going to see. So students, you have seen that the gravitational force is directly proportional to the product of two objects. As you have seen that we can write like this, force is directly proportional to M1 multiplied by M2. And we have seen here that the masses are also affecting the gravitational force. How? Less mass, less gravitational force, more mass, more gravitational force. Okay, this part is easy. Now coming towards the distance thing, now we are having that the gravitational force is inversely proportional to the square of distance between them. So this gives us the idea of this. Force is inversely proportional to the R square. And again, we can see here, if the objects are placed closely to each other, then we can say that the gravitational force that is working here would be more. And if the objects are placing apart, then we can say that the gravitational force in this case would be less. Okay, यहाँ पे बहुत सारा होगा ग्रेविटेशनल फोर्स, यहाँ कम होगा बिकॉज यहाँ पे डिस्टेंस कम है, यहाँ डिस्टेंस ज्यादा है. फाइन. नाउ कमिंग टू द नेक्स्ट थिंग हियर, हाउ टू कैलकुलेट ग्रेविटेशनल फोर्स. अब हम इसको कैलकुलेट कैसे कर सकते हैं? ठीक है, आई हैव टोल्ड यू दैट कंबाइनिंग दीज टू फॉर्मूलाज. ओके, बाय यूजिंग दीज टू वी आर हैविंग दिस फॉर्मूला. ओके, नाउ एज यू हैव सीन वी हैव रिटन G, capital G here, that is constant thing. Okay, so what is this? This is a gravitational constant. You know that whenever we have to remove the proportionality sign, like we were having these thing here, and if we are removing this proportionality sign, so we need to place certain constant value to make it equivalent. Okay, अब ये बात तो है कि हमें ऐसा एक constant value put करना होता है. All these things, like ये वाला जो part है, this part is deducted by certain experiments. Like the mass of the object is more, then we can say that the force of attraction is more. If the distance between them get reduced, so we can say that the force of attraction get more. And if the distance between them is getting more, then we can say that the force of attraction is less. Okay, now by judging it, if we have taken it for 1 kg and if we have taken it for 1 kg, like two 1 kg masses are placed at the distance of 1 meter square. Okay, so all this part, ये पूरा part तो अब चला जाएगा because 1 multiplied by 1 divided by 1 will be 1 and anything which is get multiplied by 1 will get the same result. Okay, so here we can say that the force is equivalent to the constant. That means whatever of the gravitational force we are getting here is not 1. When we have put the value 1, 1, 1 here, then still the gravitational force here is not 1 Newton. It is having certain value, and that value we have measured is known as the gravitational constant. That gives us an idea that though the minimum to minimum force is the minimum to minimum value of the masses and the distance we have placed, then also still this much of gravitational force would be applicable to the whole universe. That is the very important role of the gravitational constant, students, here, that कहीं पे भी आप चले जाओ पूरे यूनिवर्स में, ओके, स्टिल किन्हीं भी टू ऑब्जेक्ट्स के बीच में मिनिमम से मिनिमम इतना ग्रेविटेशनल कांस्टेंट जितना फोर्स तो लगेगा ही. दैट फोर्स इज द necessary to be applicable between any two objects. Okay, that is gravitational constant. कि इसीलिए हमने इसको बोला है this constant value of the gravitational force would play a important role between any two objects.